this BMO2. It's like this. You have a acute triangle ABC, and then you have these vertical lines perpendicular to BC going through B and C. Then you have like a tangent line going through T. It's called PC and PB. And we're asked to show basically that if you join this and that's Q, and PCQ is perpendicular to AB and PBQ is perpendicular to AC. Bet you that's Leon.
是不是猜谁来？看谁猜得到？
没有。
啊，你看到了？
没有。
It has to be.
There's only one option.
我是不是猜错了？
啊？真的？
我不知道啊，但是我就想。
Oh, what is this spiral C shenanigans?
Mm.
You reverse reconstructed. What's it called? So you go PB, drop PB to the perpendicular, and then assume like that means AT on BC, right? So to show PC, P is like Q, and you go to AB.
Yeah.
So this is basically symmetry when you do spiral C. Like what? How? Ooh.
Hey, Leon.
It has to be Leon. It can't be anyone else.
哎，我以为你猜的李我。
Leo's like walking across. Can't even call it. Yeah.
What? Leo?
Leo, yes.
Walking across town for
It
course.
feels like walking past like you know like chemist warehouse that corner.
Oh, he walking here.
Yeah.
他是不是坐了一个公交车停哪，然后走过来？
Wait, is that why he's late?
I think so.
But I thought he consistently comes at that time. But he doesn't consistently walk.
He speeds off. According to
Ooh.
the time. What is BMO2?
This seems way too simple. So anyone have any ideas?
SCB is the YC is the
Wait, did you reverse reconstruct this? So you make Q the intersection of AT with BC, and then you show that PQ and is perpendicular.
I'm pretty sure you can also assume like PQ like meets there, and then just like PQ perpendicular to AC.
Oh, and then you just you let the point of intersection be Q with BC.
Yeah. Wait.
random.
It's like you assume like AQC, AQT, right?
Yeah.
And, you can also assume PBQ is perpendicular to AC.
Oh,
And you just
okay.
have to show that PCQ is perpendicular to AB.
PCQ.
I'm not sure if that's. I know that might be assuming too much. Actually, that probably is assuming too much.
This is.
Okay. Well, actually, QT.
That can't be. I think I did something.
Do you have anything or is it assume? Assume, okay, good. Good idea.
Do this right. So if we prove this is cyclic, then this will be equal to that. And then that will be equal to that. So doesn't look true. What do you want to prove is cyclic? I don't think I'm doing this right.
Oh.
Can you do that? Surely it works, right? This is cyclic, and then prove this. That's not new. I don't think I'm understanding the problem correctly yet. You're saying stuff is cyclic. Tangent at T. Line through
I call PT have no respect in me. Then it missed the whole time.
that line through passes. Huh?
门口那两个呀，
What's enough explosive math?
Okay, so that's the
What's explosive? What's it? Flammable math. Flammable math.
so confused. We want to prove this is perpendicular, we have to prove this is cyclic. And then this is equal to that, and this is also equal to that. I'm really sorry. I made some severe mistake. In circle goes to Chungo. I need to see someone else's diagram.
I thought it was actually like.
Did I even do this right? What did I do?
Trace some angles. Bash some angles.
Attempted to do this intersection.
Let's just bash the whole thing.
Okay, so
Synthesis failed us. Complex math.
Wait, synth hasn't failed yet. It's only
since hasn't.
this is the last question on BMO2.
Oh, wait. Is it?
BMO2.
Oh, so four grades.
Yeah. So it's like an AMO4 kind of intention.
Why don't I feel like I'm not understanding it?
Oh, why?
It doesn't look right.
What's wrong with
Wait,
it?
unless it is right. And I'm just like, wait, it actually might be. Wait. No, but surely not. Yeah, because if it was here, then I wouldn't want.
Like the angle at Q is meant to be equal to the angle at A, right?
Angle at
And
Like
I got Q. You check.
what happened?
like I define Q to be where AT meets BC. So the angle between the red lines should be equal to the angle at A between the triangle.
Yeah.
Because
Yeah.
they're both perpendicular to the sides.
Oh, wait, yeah. Okay, hold on. I need to draw another diagram that is less sus.
I love this
So that-
question. This Q question is very interesting.
New question.
Not only
It
does
looks easy, but I don't think it's
alright.
to be honest.
Geography is probably the easiest topic in math. It's a really well because I'm just different.
Leon moment.
You should like crab game. I also teach at the school in business consultant. So I use an operator for this conductor.
So things we can try to prove, yeah? Like
No,
Okay, let's try and make this less perpendicular.
I'll just borrow one of
Way
those
less
and-
perpendicular.
oh wait, so if that's what we're trying to prove, then
What? I just got trolled 2 times by the thing.
then we could also be trying to prove
That doesn't look right at all.
Tell me this one works.
some stuff is cyclic.
Yeah, else you point lines on the minor arc.
I spent 1 year in an art school so I can draw perpendicular lines.
100 PB perpendicular to
T is any point.
AC. PB perpendicular to
We may have diagrammed it.
Ah, is it? I get it.
Get it.
And how's Q constructed?
In-
Q's constructed from PB and PC, right?
So here I made it the intersection of AT and BC.
T.
Given that Q lies on the AC plus. Okay, this is not the
Okay, this is T now.
Oh. Maybe
Tangent. What do we do?
maybe T
Oh,
has
same.
to be diametrically
That's the
opposite.
only thing. Also, ice cream cone.
T has to be what? What?
Wait, I need to verify.
90 degrees from the O.
A here, That's T is here. T is on the bottom.
I'm Daniel.
Wow.
Oh no, they're gonna steal our kill quickly. Finish
Okay,
this
so
they're gonna steal our kill.
wait, we're assuming that the perpendicular.
Oh, mine is
I
somewhat.
don't think this works. Dang.
What is the version about T?
Why is mine somewhat perpendicular?
Oh,
Sus.
we have C. Wait. Take the perpendicular so we get B, P, B, C's that intersection cyclically. So B, P, B, that thing is equal to angle at C. The angle at C is also equal to A, T, V. So then we have to make this side. So this is concluding from having George. So, wait, no, this condition's already set. So we'll conclude on this.
What problem is this?
So given that Q lies on BC,
Bless you.
given, okay. So, wait. Line through PV.
Bless you.
Welcome.
What is that? You were spotted to be a college supporter.
Me?
Yeah.
I was
Yeah,
walking,
Candace,
yeah?
well,
Like, just then?
Yeah.
Yeah, I was walking. Wait, what? Who spotted me?
Once
Someone, like,
still
driving.
among us.
Leon.
He was driving.
Yeah, I was just driving my car.
He has the classic sweater.
Yeah.
The classic light blue and the classic hairstyle.
Ah, yes.
That's like a
The Leo
special.
Hoodie sunglasses and face mask.
Is this the question that you... This is...
Yeah, BMO2 question 4.
Oh,
Did you?
So at the moment we're doing a team live sync.
Just video button.
Have you tried this one yet?
You tried only video perpendicular to face.
How hard is this?
So
This is
that's
AMO4.
back out and
Okay.
oh god.
EV and construct this.
A, B, C.
Hmm?
I, B, I, C.
Can't read it.
Oh, no, actually, this one's...
Okay, we're constructing
So you should
this.
everything down off the circle.
No, we're doing that.
Did you do it or not? Or did you just...
No, I imagine
how many times.
Wait, what? How?
I think it would be fun. Okay.
When he lives in the minor, I have a family with tangents.
Wait, how did I construct this?
Oh my god, Georgia. They won't see me contest in 2 days.
Yes, it's in 2 days.
Stop, I don't want to cry.
Okay, so then we have to do.
Lucas not here today.
Yeah, he's at ski camp.
Yeah, I remember that thing he said.
All the North Sydney people aren't here today.
That's key camp.
Number one, there's nothing that's in Paris.
Okay.
Go to the back.
Where is this?
It's in session. Number
High difficulty.
So I'm trying to do it this other way, with Q as the intersection of AT and BC.
Wait, so what do you have to prove here?
You have to prove the red lines meet at 90 degrees with the black lines. The sides of the triangle.
Oh, that'll work.
Reverse reconstruct.
But like, if they do meet at 90 degrees,
Well, I mean, if Q.
Wait, then can't you assume one?
Yeah.
Wait.
I'm pretty sure you assumed.
Wait, you can assume one of them leads to 90 degrees.
Yeah, I think so.
Like, because the assumption is that both of them intersect. Wait, no, wait a minute. Haven't you like lost information?
Oh,
Yeah, I think you've lost information because I tried doing this and it doesn't really.
really?
Because I think it's possible that they both don't meet at 90 degrees. That's the problem.
Oh.
So if one of them is
Right?
So you're saying. Alright. let's
Because
see.
the problem is like. You.
What was the question again? It was like you take the perpendicular.
Yeah, and you assume that Q lies on BC. What's the condition for Q lie on BC? Q lie on BC. Okay, I'll construct it like that. Use the original question and construction. I don't know. I don't think this.
Can this work for like many T's, or is it just like I feel like T might get restricted?
Yeah, well, definitely doesn't work for all T's. I feel like for this, like,
No, if I said many.
I thought that T had to be opposite A of this.
Wait, so that's a tangent to T, right?
Yeah.
If T is opposite to A, that's the only way.
Wait, does that mean we can assume one of the red ones is already perpendicular?
So the line is 90 degrees, and if it's 90 degrees, then
I think
B, Q,
Because
T,
that's how the
P, B is
reverse
cyclic,
construction
which means that
it's like
these two are equal.
one
and
of
these
the
two are equal,
perpendiculars
so
intersects
that's
BC at T, and prove the other one is perpendicular.
Wait, no.
And that would be the way. But then like,
Wait, is
I
that
don't
how it
know.
works?
I don't know if the other direction can work for this one because like there's specific T's which may not actually survive that.
Okay, so the conclusion is that like 5 lines are concurrent, right?
Yeah.
And the assumption is like
5 lines of concurrent.
Wow.
6 lines.
6.
No, that's coding.
That's not. I don't think I'm doing this right.
Okay, so the question says basically that the 2 red lines intersect. If you assume the red lines are perpendicular, they intersect on BC, right?
Yeah.
Yes.
And then that forces it to be where Q is, well, in line with AT. Yeah, I think that is the same as saying if one of the red lines is perpendicular, then the other one has to be. So you assume Q is on AT,
Yeah.
BC, and then you assume that.
Oh, I see.
And that's kind of like the converse. Wait, it's like
One is perpendicular.
is it the second?
Oh, if one of them is perpendicular, this one happens.
Oh wait.
This is cyclic.
Oh, it's slightly different, isn't it?
Yeah, I think it's like the reasoning is a little bit off.
It's
Yeah.
a little.
There's some
Because it might not be perpendicular.
like yeah, it could just not.
It
could just not.
Yeah, that's not.
I feel like if one is perpendicular,
I was just recently teaching that if you make the converse fallacy in geometry, it's not as big a deal.
that is true.
Maybe the Marcus will accept it. Maybe Marcus will accept it.
The converse is always true. Mostly.
Try to intimidate your way into a. It suffices to show this. Like, it is clear that unless you're dumb, this is this.
High modality.
High modality length. But I think it's obvious that if one of them is perpendicular, is it?
Obviously true.
Wait, unless this logic doesn't work, I don't think it works. I don't understand. I'm just gonna try the.
They might have to.
We've already reached an interesting point in the question.
Wait. If we assume that it does HQT, it does positive, right?
Because then you just like say that if one of QCPCT and the other one is cyclic, then the other one is cyclic, because
That's like 90 minus that. Well, which one? I should just draw the diagram.
so therefore the other one's also cyclic.
This is the nicest diagram. You're gonna draw it live, bro. Why do you want to pick like the on foot anyway?
Large size.
Well, okay. Sure.
And then
Draw this. Oh yeah. Okay, bit Benji. That's okay. And then I just draw them all.
Oh my god, it actually looks like it works. What the hell?
I think if you draw them
Wait,
anti-fold,
never mind. It looks like it works. It looks like I might have disagreed.
wait, because like if you have this cyclic quad, right? Like this is equal to this, and then you have this is equal to this. Okay, but this is equal to this, so you have to do like this is cyclic, which means that this is 90, which means that the other one's 90, which means that you can do it backwards on the other side.
Oh.
Yeah, that'll happen, but I 90 minus alpha. That's 90 minus alpha.
Right, we're already assuming the question.
Yeah, we're already
We're assuming the question so we can try and find what's the Okay.
The sussy hacks.
Yeah, that's not fussy. That's
very, very,
Big brain.
very
I
valid.
feel like if we prove it antipodal, then it
Right, ruin.
Take that point and then join to that point.
So
Get the
if it's
diameter.
not,
Yeah.
wow, that's crazy.
No
Okay,
way.
so now we just do this.
That is crazy.
So that means we join that to that.
Okay. Oh, this is gonna be difficult. Does this logic
Yeah,
work? I
wait.
feel like it shouldn't work.
Wait, why?
Shouldn't
It
work.
doesn't pass through the center.
That's also one.
Do you want to try?
It never
that
said
in-
center.
Yeah, never said
No,
anything
it's
about
anything else.
Wait, hold on. If you assume the thing, then doesn't it?
Hey,
No, I think you're right.
Look.
Wait.
Look.
Just
Yeah, I feel like this, assuming
Wait,
this
pause.
is true, shouldn't work.
If you assume the question. And you
Oh
just-
wait, no, that's alpha. Then that's 90 minus alpha. So that's
So cyclic, yeah.
Yeah, that's
Yeah,
what
well,
I'm
that's
saying.
90 degrees.
So that has to be 90
That
degrees.
does have to.
Oh,
That's
it has to
already-
pass through the
Yeah,
center.
yeah, that's what I.
Oh,
It has to.
Pass through the center.
Wait, that's 9.
Is
Pass
it?
through the
He would
center.
have to be the answer for
Yeah.
anti.
Oh.
Yeah,
Yeah.
yeah.
So it has to be one specific point.
Wait.
That's why it looks like.
Yeah, but we're kind of assuming this is a line.
But you're
No,
saying
we're
We're
like-
assuming the question.
only one
You
T
can't
works.
really.
T
You
has to
can't
be
really
that.
just logic.
T has to be
Just
the
say
answer
that.
for the way.
What's
That's the only point that works.
That
Yeah.
could work.
That can work. That's the fastest solution.
I think that's that's what I.
But does that solve the problem?
If this is
I think
alpha,
so.
Yeah.
If you just
Yeah.
you
This is
choose
alpha.
T, you
90
choose
minus alpha.
you angle
This
change
is
everything. Angle change.
Oh, yeah, so
everything.
you-
It's like it's infinite.
Try and
And then
get T such
You
that
show
it
that
coincides
if it's
with
T, T is the only point. I mean, antipode is the only point such that this can work.
Yeah.
Yeah, yeah,
And then you show it works with the antipode.
Alright.
yeah.
That's taking the converse to another level.
Dude, what just
Reverse
this logic is very soft, but let's see. How do we angle chase the?
So you're saying you can assume both of them are right angles. That's what you're saying.
About that.
Yeah.
Okay.
And it's like
I don't have
Bro, I was doubting myself a little too hard. Actually, that totally. Yeah, that didn't work.
This is like range.
Yeah.
Range here.
Okay, so now we pick a point that is not. Okay. Pick a point like this. Then we do this. We do this. And we do this. Okay, if this is true, then this is cyclic. So this is a
If we
thing.
assume Q lies on BC,
Okay, so now we just say that this is.
Just assume.
Oh,
this is
now we just
straight
have to
line.
angle chase for something. Oh shoot. Okay. So
we assume that isn't a straight line.
this becomes it. Okay, well this still
Get that.
kind of works. Still kind of works, but not exactly. It doesn't exactly. Oh, but we have the theoretical point over here. Jeez. Oh, you can try to. Ooh, wait a minute. Wait a minute. So this point isn't this point. It's supposed to be this point, but it isn't. Okay. Wait, bro, this is like 500 IQ reverse reconstruction. You don't.
Wait, so did you prove there's one point that works already?
I'm pretty sure they can only.
No,
I mean,
technically it is.
yeah, if it's an antipode, then it definitely works. I think. Wait.
No, I think antipode is the only one that works.
Yeah.
Because you assume
yeah.
the condition and you try and see what point that has to be.
Yeah.
Wait, so the antipode works?
The antipode is the
The only one that works.
I think it's not that hard to prove that antipode works.
Yeah.
I mean, if
you just assume it.
Oh yeah.
Okay,
Wait,
now the only thing we need to do is prove that the antipode works, isn't it?
Didn't we already?
Is it?
No, we didn't technically prove that.
Okay.
No, you need to prove that if it's the antipode, it reads.
If you assume the question condition and then you find out the only point that can suffice that is the antipode, and then you check for the antipode.
No, I think it's because we assume both conditions, but the question is assuming one of them. So, like, you assume that AQT is collinear and they're perpendicular.
Yeah.
And then you deduce that the antipode satisfies that, but you don't know that just the perpendicularity.
Oh wait, we'll go
Yeah,
there.
like. Yeah, you don't really know.
That's true.
I don't think we have to actually do the question. Instead of yeah, but at least you try to read the question.
We try to cheat our way through.
Or just the opposite. Oh, okay.
Oh, there's some crazy logic going on here.
Wait, what is this logic? My brain's too small.
So I think they're saying you're not allowed to assume the conclusion, like, let's see.
Oh, no, you can assume the conclusion to know what you're supposed to do. You can't use it to prove the question. Oh, with this one and what the fuck? No, I was talking about these.
Similar triangles.
Oh, is it the antipode? I just need to prove the difference. Yeah, 90 degrees. I think. You get a lot of this in there. If I prove this is 90 degrees, what else is it equal to? This is also 90 degrees.
Yeah. Oh, that's already drawn.
My bro. Oh, but that's like okay. I need to look for a nice angle to fill this.
Maybe this tangent thing is needed though. I'll use it later. Okay.
Okay, I'll use the alternate segment. How do you prove it's the antipode? Prove this is 90. This is here. We can use that as an angle for this. Okay, so alpha. Let's prove this is 90 minus alpha. Ooh. This is alpha as well. This is alpha.
Wait, okay, maybe we should do like the perpendicular is positive BC and then prove that maybe take the line through A down and then it's tangents like that.
Oh.
Yeah. Wait.
Oh.
So wait. How are we gonna wait? No, that's off.
That's not a bad idea.
No, but then how are we going to define B?
No, you can't.
There are. Let's just assume that there are points here. Like no, there are points such that there are the point on the perpendicular.
Yeah, it's like a pedal point on BC.
Yeah, and then like if the perpendicular is positive BC, then we know that we must prove this tangent or something like that. Like the line. Which point? Like the line. What do you mean?
This is angle A.
Huh?
This line.
Oh yeah, so we're choosing. We're saying choose arbitrary 2 points on the perpendicular, and then let the perpendiculars go down.
Yeah.
If that perpendiculars intersect on BC, then the line is tangent.
Oh wait, but it might not be like that's a stronger version of the problem.
That's why we're doing it.
But I don't think it works. Like it might be because you can.
No, it won't lie on BC then.
Like can't you go like?
No way,
This is quite different.
No, it can't. It definitely can't. I can I can bet you.
Are you sure?
What if you just
I,
put random?
that this is still the only one that was correct.
Wait, never mind.
Can't you like can you just like shift them a little and then
Yeah, because like assume one works like it's 10, then shift
yeah,
one
and
up a bit.
then, you get
Oh wait, well
more
that's so
stuff
it's not
that
a BC. Actually,
no, just construct
never
just
mind.
construct one.
Yeah, it's not.
Can I assume that they're perpendicular and it lies on AT and then try and do
No, wait, what is? Oh, it's just a random tangent. It's just a random.
It's a random tangent.
That's illogical. That's not a better way of doing it.
Yeah, we have a lot of cyclic stuff. Right? What are
everything
we
is
gonna do with it? Huh? What are we gonna do with it?
this is psychic and all our problems will be solved.
Crap, maybe this is cyclic that we're done.
Oh yeah, Daniel goes out and circles every single point.
Yeah. This point is important.
Everything is important.
Yes. All of the points are important. Okay, how do I do this? Alpha.
Don't forget transversal.
Transversal waves.
Well,
Ah, this is hard.
construct the square. Seem to chord.
I'm a quarterback.
Complex fashion.
I need a brain to help me process this. Someone.
Okay.
I don't have brain.
Okay. What's
Is this statement like if I prove this statement, will I prove the question?
What's that?
This point is like
So I define
Well, I feel like you could maybe
define Q to be where AT intersects BC, right?
Yeah.
And then I assume PCQ is 90 degrees.
TCQ. PCQ.
And then
And then I prove that the other one's 90 degrees.
Yeah.
I feel like if the other, it's like for some reason this feels more.
Well, I don't know how to use the logic.
How is? Oh wait, what? No. Think about it. If let's say we have A.
What's
Let's say we
wrong with
take
this logic?
a line to Q
I
and
don't know how to
then
do this.
that's some other.
So you're trying to prove that.
We enter the intersect at that line.
So the original assumption in the question, right? You have these two 90 degrees,
No.
and you assume
this point.
they intersect.
It's like
Oh crap!
wait.
They intersect on. Who did that?
I was doing JoJo.
Who threw the Pokeball?
Why the fuck would
What's
you
going
do
on?
this?
What are all these lines?
Probably Leon because
What?
he's the only one who found it.
Okay, that's English. Okay.
Yes, very likely.
Another different.
This is straight line. Okay.
Wait,
This
so the
angle-
point lies on BC, yeah?
Yeah.
That's the assumption, yeah?
Yes.
And you're trying to prove
This
it's
angle
collinear with
It
A
might
and
not be
T.
90.
And
You don't know.
which does equal that.
Q has on
This
BC.
cycle as well.
Assuming these are
So you get-
collinear.
Which when you get these
Then you can do like
That's not-
reverse
you have to
reconstruction.
actually that line.
Okay.
Oh, see.
Here.
What the fuck? Yeah, that's what happened.
Oh shit! You actually assume
Alex
it's right.
It does. It does have to be.
Catch Alex.
I don't think you can see that.
What? Yeah.
this angle, isn't it just is this angle? Oh yeah. Okay.
Einstein.
So
Einstein.
Does this work?
Yeah, it's like that.
Second or third.
Bro.
Oh, shoot.
no, but if you prove any one of these two are cyclic, then you're done.
Huh? Which one?
Like any one of these 2 points are also cyclic.
That ain't working.
No, you have to believe.
You have to believe, and
I think you can prove one of these is 9, can't you?
No, wait. What?
No.
Should
That
that
was at the same speed.
That's right. I'm drawing on okay. Go back.
I'm not thinking the complex.
It's about like how it's.
Oh wait, this might actually work.
No, I swear you can just prove one of these is 90 and you're done.
I think, yeah, wait.
Prove one of them's 90.
No, I'm just doing the problem like as it was meant to be.
Oh.
Yeah, just do it.
As it was
And just reverse switch it.
Alright, so let's see. A equals A.
The
B equals B. C equals C.
The problem as it was meant to be done.
So PB.
What does that mean?
Okay, so let's set a T.
Oh, the problem as it was meant to be done.
Maybe the center might help.
How do we get the tangent to T? So it's like OT is perpendicular to TB.
Yeah.
Oh, sorry, TPB.
Yeah, actually the problem as it was meant to be done.
Yes.
It's still because I have the complex backup.
Yeah, the complex match actually seems nice.
Yeah,
Seems
the complex
really
match isn't too bad.
It seems to work even just as well.
Yeah, the complex match seems really.
The negative bar of itself.
But we should all start the complex bash together after we.
Right. Laid
Oh.
to rest.
Oh no, you can do it now if you want.
Oh, wait a minute, because if I like do this, if I make them coincide. Wait, hold up. Oh, this is interesting. This is more of a logic problem than a geometry problem. Hey! Oh, I'm listening, what? I'm not tripping, right? Like, you can do the same thing on the left side, yeah? Yeah, wait, what? Oh! And then you get these four cycling and you're done. Wait, no, just like, you get these four also cycling. Wait, surely. So then you get this is 90 and this is 90 and you're done.
Yeah, that's like the most stupid argument I've ever seen in my life. But yeah,
But it works!
It works.
No,
that's so stupid.
He was mocked for his arguments.
That's so stupid. Yeah, that works.
Okay. Yeah. So basically, on this side, you get start from alpha.
Let me actually draw the problem.
But this
I haven't even drawn the diagram yet.
This side here. So the heck? But these are not straight. Okay. Just use your imagination. This is a straight line. Alright. Okay, alpha, so you get alpha. Yes. You get this is alpha because this is cyclic. Yeah. And then you get this angle is alpha because these four are cyclic.
Yes.
Okay, so that gives you. Wait, how's that cyclic? These four cyclic from PowerPoint, according to Frank.
Yes.
Oh.
Yeah.
Because you use some similar triangles stuff.
Oh.
Is it?
So this is the actual problem here, see?
Yeah, okay. So that means you get 1, 2, 3, 4 cyclic.
Yes.
Right, by bow tie. Okay, then you do the same thing on the other side. Beta, beta, and then you get beta. They're both so then you get these four are cyclic, or these four are cyclic.
Yeah.
Right?
Yeah.
So then you get this is 90, and you get this is 90, and you're done.
Oh.
These are now the same. Okay, that's crazy.
That's tangent proof. It's literally a proof for a tangent.
Yeah.
So it wasn't that bad.
No.
You just have to do the problem.
What is it?
As intended.
Is this how you started?
No, it was a reverse.
Like, wait, how do you know that's
Yeah,
right?
I reverse. You draw AQ and intersect it.
Like, how do you know that's
like
right?
some other
It's
point?
assumed.
That's weird.
It's in English.
Oh, yeah, that's like the question.
No, but you
So
also
it's the
use
question.
this.
No, we like this is the line, but it's not the line. Like this is the
We
line.
try contradiction.
Like
The line
we
goes
the line AQT we didn't assume it goes to T. Like some T is like some other point here. This AQT is like hitting it here.
Oh, you're just so like you draw a you connect
Yeah,
A to
again,
some
you
point
intersect it.
and then prove that that's T.
Yeah.
Oh.
Wait, hold on.
Wait, so you did this. You connect this.
Yeah, and you hit it at the circle at some T
It's
prime.
S.
It's the line, but it's not the
Okay, S. And then basically you intersect CS with the tangent, and you intersect BS with the tangent,
Oh crap.
and you prove they're the same point.
Yeah.
Yeah. Wait, that's so
BS.
dumb. Wait, this might be.
Yeah.
Yeah. So basically, you can prove that the Q, C, P, C, and
the new point you just made.
Alright, so this is
Like,
Q.
bro.
QC, PC,
And the
QC,
intersection of the tangents.
QC,
PC.
PC.
And this new point down here. Is
Oh.
cyclic.
Okay, so like here. Like
Wait,
Q.
no. The one at the bottom.
Oh.
Yes.
Diagram dependent moment. Yeah, so
So you want to prove those four cyclic.
that point QC.
And you just angle chase that.
Wait, when did I even join? How did that line even come about? S. Did I join that just then?
Yeah.
C to S, right?
Yes.
You want to prove QCPC at that point
Yes.
on
Purple
X
point.
is cyclic.
Yeah.
Oh.
Important observation. This side. I think that's very crucial.
Oh, and then like reams or something. Wait, hold on. What?
Reams. Reams.
P-
What's going on?
I have to squint.
What's going on?
So we angle chase. So we ankle chase.
So you're saying QCPCX is cyclic, yeah?
Yeah.
Yeah.
QC.
Use all the cyclic chords. And you eventually get it.
Unleash all of them.
Oh, so it's not like a one-liner.
This is like 3 cyclic chords. That's there's this one, there's that one. You can start with QCS,
Yeah.
and then you move it to B. You get BAS, and then BAS, and then you get the perpendicular CQ. Oh,
Here.
use that cyclic chord there. Oh yeah, you get. Yeah, and then you have to prove one more cyclic chord, and then you're done.
Ah, that's my power.
So yeah, you have to prove PB, PC, and the P of the cyclic. Yes.
Yes. Indeed.
Is that is okay. Wait. What?
What's up?
I don't get it.
Bro.
Bro.
What's wrong? What's this? Okay, I see.
See what? See what? What do you see?
On a slide cycle.
Oh, is it cyclic?
That's a 4.0.
QCPCX.
Oh no. You have to prove
You have to prove
those 4 cyclic.
this is cycle.
Oh that.
Oh.
That's
Yeah.
just do the sanity check.
DE. Yeah. PB, DE, PC.
Make sure I'm not tripping.
Oh, those are cyclic.
Yeah.
Is that believable?
Oh, because you get like PBQ times QE equals to QB.
This over this equals this over this, which is this over this.
Yeah. You do power point. Wait, how PBQ times
Because they're
QE?
all right angles, right? And it's like vertically opposites.
Oh, they're similar.
Yeah, they're also
Oh.
Oh, I get it. Yeah. That was
powerful quiz.
Oh. That is not easy to see.
that is a very strange.
So you're using these right angles here.
Yeah.
Yeah, I don't see any other way to this.
Complex bash.
Complex bash.
Yeah, we'll do complex bash right after this. So let's see.
Yeah, but then this one.
Yeah, I think that's like the neatest way to do it.
Yeah.
Even though I can't see any other neat ways.
It's the neatest by default.
How did you get this so quickly?
Yeah, I can't see anything else. Maybe like. Perfect.
Disus legitus.
Oh. So some kind of the ratios are the same by cosine or something.
It just is.
Trust in the process. It works, bro. Trust. Just trust me, bro.
Just trust me.
Believe me.
Bro, wait, that's so intelligent. What the heck?
Proof by trust me.
How do you even see that? Bro, speedy. How do you even see that? Oh.
Can we make a complex bash version? Snake the intuition.
Snake the intuition.
Definitely don't need the reverse reconstruction for.
You definitely don't. Complex bash is
Yeah, you just have to do it.
Just do it.
It's definitely. How do you even see something like this? Man? That's kind of crazy.
What is it? BMO2.
Bro, this is actually.
Oh, I mean, complex bash.
This is basically like flattening your legs.
I think you can assume it's antipode, and then you go.
Unless there's like you need to make sure everything's different.
No, you need to make sure everything is differently, and everything kind of you do in a linear way.
Oh my gosh!
Like,
What
there's no
the hell?
squaring.
Yeah,
There's
you
no
use the
squaring.
similar
You
triangle.
need to go
and
backwards.
it's good. Like as long as you can
But I
go.
feel like he was explaining the fallacies in our logic the whole time. Where did you have time to even find this?
Oh, I don't know.
But
Dude, this
Like,
is
once
kind
you
of
get
a
one that's
crazy.
And then you just realize, oh, do the same thing.
So it's like this, right?
Do the same thing on the other side.
Okay, so if
Yeah.
the fourth DEPVPC is cyclic, yeah, then you get purple dot from the. So it's the four purple dots are equal, yeah.
Yeah.
So QX perpendicular to PBPC.
And then the next claim is like, what are you doing the other side? Y cube
Yeah, for the symmetry.
Y cube B PB is cyclic.
Yeah, for the symmetry.
Wait, because you can just translate the 90 degrees to the other.
Exactly.
Through by symmetry.
Yeah.
Yes.
And then you get QX is perpendicular to BBPC, and then QY is also perpendicular. Oh damn!
Wait, QX.
What is this here? Like from the cyclic chord, QXPC is 90, and then from the other cyclic chord,
Oh my gosh.
QYPB is also 90.
Yes.
Oh, 90. Yes.
90 degrees. 90 degrees.
So that proves that X and Y are equal. So that proves the
Dude,
line.
What? This is kind of insane.
The line is touch the circle there.
Bro, what is this argument? This argument's kind of like. How do you even think of this?
How do we bash this?
Alright, at 11 o'clock we bash.
We do
What
it.
we
Why are we
like.
waiting till? Oh, one.
Okay, let's recount this argument one more time, okay? So we have cyclic chords A, D, E, Q, yeah? A, D, E, Q. So these two angles equal by bow tie.
Yeah.
And the given cyclic chord, well, A, B, S, C equals those two angles as well by bow tie, yeah? And so then we're just trying to show that it equals D, P, C, P, B, yeah?
And then you use some similar triangle black magic to get power of a point.
So then you show that the DEPVPC is cyclic.
Yeah.
And in some sense it has to be, I guess, so that's reassuring. And then
Yeah, good.
the power of a point.
Good. When you basically compared the lengths to BQ and CQ,
So it's these.
and then
It's
it just
it's
works.
this power
What the heck?
is equal to the red power, and then the other one's also equal to the red power.
Oh,
So it's using cosine of like this angle, and then
yeah.
cosine of this angle.
Similar triangles, just use
No, you just need a PowerPoint.
No, like
just similar.
It's PowerPoint. No, it's just PowerPoint. It's just PowerPoint.
Yeah, yeah.
You have B pro.
but you have to
So
establish
it's like
the powers.
B on the
No, but then like you have B2 CE and then B B C C. There's so.
Okay.
Oh yeah, you can do
That's
that.
how it is.
Yeah, it's kind of crazy, dude.
Yeah.
What?
BMO2,
Oh, yeah.
not an issue. I remember the BMO2 last questions are not easy.
It's like AMO, right?
Yeah, and this was one of them.
Yeah.
This should give you
This is for
confidence.
sure easier than AMO 8, right?
Oh,
Than both AMO 8s.
for sure. I
I
mean,
didn't solve.
no, but see, like that was you 6 months ago.
True. It was also I only had like half an hour. True. So, yeah. Yes.
I mean, you solved this in like
Yeah,
20
you
minutes.
solved this quick as well.
But I had help as well. I don't know. Daniel
genius
somehow just saw this genius.
the cyclic quad.
Oh,
Stop
crap.
standing on the
I heard a crack.
Yeah.
Oh no.
I'm kind of praying for the aim of last question to either be a geo
Functional
or like a
question.
Functional question.
There's a functional equation that I'm freaking set, bro. I'm like, you know,
Alright,
let's go. But if it's a comic, I'm like,
bro, if it's a functional equation, I'm screwed.